Hi thinkers, welcome to ThinkX Academy. In this machine learning playlist, we have already studied the perceptron learning algorithm. In the previous tutorial, we have briefly studied the representation of perceptron. In this tutorial, we are going to do a solved example which will basically help us in understanding more about how a perceptron exactly works. So let's take a look at the question. This is a question which says implement AND function using perceptron network. So we will have to use the perceptron here, you can see, and it is for bipolar inputs and targets, right? So bipolar basically means 1 and -1, bi means 2, and inputs and targets are this, right? So we are not given any data set. We will have to make a data set using the question itself, right? So let's try to make a table here, and in this table I will try to write all the inputs and the outputs. From this question itself we will have to see what are the inputs. So bipolar means we will actually have two inputs, x1 and x2, and the target will be a 1 or -1, right? So this means that we are actually doing a binary classification. So targets can also be 1 or -1. So it's written here bipolar inputs and targets, right? So let's name the first input as x1, then x2, and let's say the target is t. So bipolar means 1 and -1. So we will first write 1, 1, -1, and -1. In x2, I will write 1, -1, 1, -1. And now since this is, we will have to implement AND function, we will do the AND of these two inputs. So 1 and 1 will give me 1. If there is any negative, we are going to write -1. Here also it will be a -1, and here also it will be a -1. So this is how we implement AND function, and this is how we have this is basically our data set. You can consider that this is a data set which we have just seen the question and we have just implemented it here. All right, so now what we want to do is we want to train the perceptron, and basically we know that in a perceptron we have the input features x1 and x2, and then we make two channels with weights w1 and w2, and we add a component here and then activation function, and then we get the output as 0 or 1, right? So we actually perform the operation to get the result or the output y, right? So y will be equal to, we have studied that we can actually write it x dot w plus the bias. All right, so now the step one of solving this problem is to assume, to make some assumptions, right? It is, the assumptions are that we will first initialize. Step one is to actually initialize all the weights as 0 and even bias as 0, right? So initially in the first iteration, basically we know that after computing the values, after getting the output, we check it with the data set, and if there is any error, we add that error inside of the weight in order to make an updation, which is by adding alpha times the error in the weight, right? So we again go back and we do it iteration after iteration. So in the first iteration we are performing, this is the first iteration, so I'm going to just write here iteration 1. In iteration 1, the step 1 is to initialize all the weights and bias as 0, and we will, for the sake of simplicity, we will take the learning rate as 1, right? So learning rate is equal to 1 and weights and bias are all 0. All right, so in the first iteration we are performing the step 1. Let's move on to the step 2. right? So we have initialized all the weights, which is W1 and W2 is equal to the bias, and this is equal to 0 and alpha equals to 1. We already know that. All right, the first task is to calculate the net input, right? So I will just write it here. The next task is to calculate the net input, right? Which is basically we are going to perform this equation, we are going to perform this operation, and we will find out, then we will pass it to the activation function. But before passing it to the activation function, we will have to calculate the net input from here, and then we will pass this net input to the activation function, right? So let's calculate the net input, which is yin equals to, so now you can see the bias is 0, and since weights are initialized as 0, so I will basically get 0 here, which is yn equals to 0, or I can just write it like this: w1 x1 plus w2 x2 plus bias, which is equal to 0 plus 0 plus 0, which is equal to 0. So what I've done is I've just applied this formula here, and I've got the net input. Now we will pass this input, which is the step 3. In step 3, we will pass this input to the activation function or the sigmoid function, because in this case we are going to use the sigmoid function. All right, so in order to calculate the the sigmoid function, we already know that the final output y will be equal to, we will give the y input to the sigmoid function, and you can see the yn is actually equal to f of 0, and we know that when the value of from the sigmoid function, we know that if the value of this is equal to 1, 0, minus 1, in that case we assume that the value of if value of y is 1, 0 and minus 1, and the cases are, we have already written the cases, which is y of n, which is this one, should be less than, should be greater than theta, and in the case of 0, or just write it as 0, should be greater than 0, and minus 0 to fin and 1, we have this one, or let's write it as theta, where theta is basically the weight that we are introducing, and similarly for minus 1 we have y input less than minus theta. So basically it means that if f is 0, fn is between this one, which is less than 0, we can also, for the sake of simplicity, I will just write it like this: fn, if the value comes out to be if the value of fin is greater than 0 and if the value of fin is lesser than 0, we assume that the values are of the this fin is 1 and 0, right? So you can see that if the value of this, and let's introduce an equal sign here also, so if the value of y input, which is the net input, is 0, the value of fin is 0. All right, so now we have the value of the sigmoid function. So we will pass this, and after passing it, we have classified it as 0. So what is the value of y? Equal to 0, which is the predicted value, right? So now we will tally it with the database, sorry, the data set we have. Since we were evaluating x1 and y1 was 1 and 1, so this is for the first input. For the first input, the value of x1 is 1 and x2 is 1, and the output that is coming, which is y, is equal to 1. and you can see that the y that is coming here is equal to 0, and since it is not equal to the value that we desire, we will move to the step 4, which is to update, which is to basically update the weights, right? So now we will update the weights. Now this is an important step. After doing all this, after just checking the value of y, which is here, and this one, after comparing this, if this is not equal, we will have to update the weights, and we will do this iteration after iteration until and unless the values of y, which is coming after calculation, becomes or starts becoming equal to these values in the data set. All right, so updating the weights. So let's see how we should update the weights. The new weight will be equal to the old weight that I have plus alpha times t of x1, because we are assuming the first input, so we are going to write it like this, or in place of this you can also write delta w, right, which means the error that is coming. All right, so we will also have to update the weights and the bias, right? So we will have to update the bias also. So the new bias will be equal to the old bias plus alpha times t, right? So in this manner we update the bias and the weights. So this is a very important step here. Step 4 is the updation of weights and the bias. All right, so let's do this step. Let's try to update the values of weights and bias. So w new equals to w old plus alpha times of this, right? So let's see what will be the value of w1, which is the new value. So the old value of w1 was equal to 0 because we have initialized it at 0 in this step. So it was equal to 0 plus alpha is given to be 1. We have assumed it to be 1. Then t is the actual output or the target, which is 1. And then comes the x1 is also 1. So the value of weight 1 will become 1 now, right? Previously it was 0, now it is 1. Let's see what will happen to w2. We will also have to update w2. So previously it was also equal to 0 and the learning rate is equals to 1. Then t times x1 is basically t is 1, and for w2 we will use x2, right? For w2 we will use x2, so I will just write xi here, and basically x2 is 1 also. So now the weights have become 1 and 1. Let's see what is the new bias. The value of old bias was also assumed to be 0. Initially we have initialized it as 0. The value of alpha is 1, the value of target is also 1. So the new bias that we have is equal to 1, right? So now we will use these new weights and these new bias in the iteration. Sorry, this is the first iteration. We have only done the first input. For the next set of inputs, we will consider these weights and these bias. All right, so let's move on to the next input, which is x1 equals to 1 and x2 equals to -1, and the value of target is equals to also -1, which you can see here. Now what we have to do is we have to move to this step, which is to calculate the new input, right? So let's calculate the new input, which is equal to x1 w1 plus x2 w2 plus the bias. And remember, the bias and weights have changed in the previous step. So x1 is equals to 1, w1 is not 0, it's now 1, you can see here. So I will write 1 here plus x2. x2 is minus 1 and w2 is 1 plus bias. What is bias here? You can see it has come out to be 1. So 1 will cancel from here and we will get the net input as 1. Now after calculating the net input, we pass it to the activation function, right? So which will give me f of 1. So the value is greater than 0, so we will assume it to be 1. You can see this one here, right? So the value of the function, the final value that we have got is equal to 1. Now we will have to tally this value with the graph with the data set here. The value of function was equal to 1, which does not matches, so we will have to move to the step 4, which is to update the weights. And similarly we will update the weights also. I'm going to do all the steps here. W new will be W1 will be equal to old W. So old weight was equal to 1, right? Here you can see that the old weight was equal to 1 plus alpha remains the same. Target is now minus 1 and x1 is 1, right? So this basically gives me 1 minus 1, which is 0, right? And in W2 we will write the old weight was equal to 1 plus alpha times target and x2 was equal to minus 1. So W2 will be equal to 1 plus 1, which is 2, right? So these are the new weights and then we will get the bias, the new bias. So the old bias was equal to 1 plus alpha times t, right? So alpha was 1 and t was equal to minus 1. So what will this give me? This will give me 1 minus 1, which is again 0. So iterations, after iterations we will then move on to the third input and then the fourth input. You will observe that when you will move to the fourth input, what you have to do is, these are the same steps that you have to do. I'm not doing it, I'm just leaving it for you. What you have to do is you have to use these new bias and new weights, and then you will have to move to these steps, which is this one, and then you will have to check whether the value of y is equal to these values. You will have to tally it with the data set. Alright, so let's observe at these two tables that I've created for iteration 1 and iteration 2. You can see we have 4 inputs in both the iterations, and what I've just done, I've just noted the values that we have calculated. You can see the value of x1, x2, the target, yn, and the y, which is from the activation function, and the change in w1, w2 and bias, then the weights w1, w2 and the bias. You can see this is the table that I have constructed, and basically we have, in this tutorial I have only calculated the input 1 and input 2, but you can do the same steps to get these inputs also, and similarly all of these inputs also. You can actually construct a table. Now observe the input 4. You can see at the input 4 there is no change in the weights and the bias, so it means that actually it is matching with the table. And you can see the weights that we have got from here is 1 1 and the bias is minus 1. So it means that if I will use the weights w1 w2 and a bias of minus 1 in the perceptron, basically I will be able to get a line which will be able to just do the binary classification, something like this. Let's say these are the two classes and it will be able to do the classification. In the iteration 2, you can see again we have the same values, and you can see the change is now, once it is 0, it is going to be 0 all the time. So there is no change in the weight 1, weight 2 and bias. There are no errors in it. and you can see that the weights are constant here. So the iteration 2 is basically to confirm that for all inputs we are actually getting we are not getting any error, right? So that's for the iteration 2. So that's all for this tutorial. If you have understood the concept, please make sure to like this video and subscribe our channel for support. So that's all for this tutorial. Thanks for watching.